For the digital output we have two tests to make, one for the 3-wire digital output and the other one is the two-wire one. So let's start first with the 3-wire one. So for that we need to assemble the following circuit. So we have a battery, that is I have right there, and it supplies power to our connector. Also we are going to measure its voltage on channel B, and the signal that is coming back is going directly to channel A. The ground is going to the Pico ground connector over here. So I have everything pre-assembled. Now let's see what happens when we turn on the device and put the slide switch to the digital position. We are still using our multi-vibrator set to 2 kHz, and we see that we have a square wave on the channel A, and channel B is a steady battery voltage. So let me just put on a trigger in a good position, and we can see it more clearly that we have 6.5 volts on the high and 200 millivolts on the low signal, and the frequency is in the bottom corner, 2.4 kHz. So it's all good, and with the multi-vibrator we can always, let me just rotate the trimmer, we can make this different frequency, no problem at all. Next we are going to check how the digital 3-wire output works with the arbitrary wave generator. So again I will connect the AWG lead to the device, and we are going to power it up and switch the source from the multi-vibrator to the Pico AWG in. So what we have, let's say, see, without a trigger we have nothing. And now let's turn the signal generator on. We need at least 1 volt, but 2 volts even better. So with 2 volts, 1 kHz square wave, we are getting a nice digital square wave. And we can see over here that it is 1 kilohertz, and again it goes from 200 millivolts to 6.5 volts, which is the battery voltage. Now we can play with the arbitrary waveform generator, and let's say generate a duty cycle. So let's say we have 1 cycle, we have the signal going from minus 1 volt to 1 volt, and let's say we have duty cycle 20%. Okay, so it's important that the square wave in the Pico AWG goes from -1 to 1, because that's the low and high values that our device interprets. Do not try to use 0 to 1, it might not work correctly. So once we try that, we actually have a square wave again, pulses, but with a smaller duty cycle. We can use the measurements to check that they are actually correct. So on channel A I'm putting the duty cycle measurement, and the value is 19.5%, which is very close to 20% that we instructed. So it just works, and you can actually use the arbitrary wave generator to produce more interesting waveforms that, for example, correspond to the camshaft signals. So you can have a fat window signal. Let's try this one. Okay, the trigger is not happy about the different sizes, but let's stop it and see that it's actually a smaller signal and then a larger pulse in time-wise, and then it repeats itself. So we can actually produce arbitrary pulses with this technique, and it all goes from 0 to the battery voltage, not from the Pico plus minus 2 volts. So it will be in the right range, and the circuit that you are testing should be able to understand it.